Hey everyone, so today I'm going to go over some of the concepts around diffusion and lipids. So I think the first thing I want to start off with is the idea of bilayer formation. So really when we're looking at bilayer formation, we can think of lipids having this bulky hydrophobic head, and then like this is the classic picture that you'll see. So really what we're looking at is this head that's hydrophilic, meaning that it's water loving, and then the tails are hydrophobic. And so and so when we're thinking about what that means, really like zooming into the structure, you can think of what would sort of make up each sort of segment. So in this polar head group, I'm not going to draw the whole thing out, but basically you have some charged atoms, you have some permanent dipoles, you have a couple carbon-hydrogen bonds, so you do have some induced dipoles in there as well. So this should just get you thinking in terms of what interactions can form between those groups versus in the tails, like it's just a bunch of, it's just really like carbon, 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 with hydrogens all around, right, and so on. Like it's just fully saturated fatty acid chains, which really just means like carbon chains that are saturated with hydrogens. So when we think of this, like I mentioned in my last video, really the idea is you have a carbon-hydrogen bond. This bond is non-polar covalent, which means that the possibilities for carbon-hydrogen interacting with other things can be anything with ID and then like something else. So you could have ID ion, ID ID, and ID PD. So that's like the main idea when looking at a phospholipid. And now in terms of its shape, really like the way that I've drawn it, I mean, I'm not an artist, so I can't draw to scale perfectly, but the main idea is that with the phospholipid, so you'll either see it drawn with like this or like this, and the reasons behind that you'll talk about more later on. But really the main idea is that this forms more of like a rectangular shape than a lipid that only has one tail, because I mean, in terms of like the surface area, this forms more of a cone shape. And so when it comes to bilayer formation, it only really occurs with phospholipids that have those two tails, because the geometry of the molecule really allows for this like sheet to form. So they really can like line up, right? And they can interact with each other. And so you can like picture this kind of situation where in between, so here like in the center, I mean, there isn't actually a space there. I didn't really draw it that well, but really like these tails are interacting with each other, and they're also interacting with their neighbors. And like we discussed over here, these are all carbon hydrogens in those tails, so really the main interactions you're going to see here are ID-ID. So that's just to conceptualize like kind of what's going on there. And really the most important thing is that lipid bilayer formation is spontaneous. And that really means that potential energy is being released. So when these come to form together, this process is spontaneous. And so the delta G is less than 0, as in like what we're saying is that potential energy has been released from the system. So I just want to quickly touch on the other types of sort of lipid formations. So the other thing that we can talk about is with this two-tailed lipid. You can also get liposome or liposome. And the main idea between a liposome and a phospholipid bilayer is that a liposome is sort of just like a smaller version of that. So you'll have like this donut shape and then kind of this idea all the way around. And so this core can be used for a bunch of things, but it's mainly used to transport things. But when we're thinking of a cell, we would imagine this like a lot bigger, right? Because the whole like now needs to, so this is your bilayer. Now this has to hold like, right, your nucleus, all the organelles, everything like that. So you kind of can like picture the cell as just like a blown up version of a liposome. The other thing that I just want to mention quickly is with this cone-shaped lipid. So with this cone-shaped lipid, you can really kind of think of it. I mean, it is three-dimensional. I don't want you to forget that because I'm going to draw it as 2D, but it is a three-dimensional object. I mean, everything is three-dimensional, right? A cell is like a ball. It's not actually like a circle. So, yeah, so we can think of these kind of as like pizza slices. And when we cut like a pizza or a pie, the way that lines up is in this, right, in this circular form. So just to illustrate here what's kind of going on. So the difference, if you can notice, so this is my cell, is that here we have like a hole in the middle, right? This is empty space that can be filled with things for transport, all that stuff. But here we don't have this, like the hole in the middle. Really, this is a hydrophobic space, whereas here I'll draw it in a different color so it's more clear. So yeah, this is a hydrophobic space, whereas in here we really have a hydrophilic space because what's interacting with that hole is the heads of the phospholipids instead of in the micelle case it's really the tails. So hopefully that was helpful in sort of illustrating some of the concepts we talked about in class. And yeah, I hope to see you in another video.